Okay, so the lesson today is on lateral area of prisms. First, we're going to talk about the characteristics of prisms. What is a prism? It is a 3D figure. So 3D means 3 dimensions. It has a length, a width, and a height. So 3 different dimensions. Imagine something like a cereal box rather than just a piece of paper. It has 2 bases. What is a base? Well, we're going to get into that, but the characteristics of the bases in a prism are that they are parallel planes. So think about 2 pieces of paper that will never cross. The planes are parallel. So just like a parallel line, which will never cross if extended forever, a parallel plane is like 2 parallel lines, but they are pieces of paper rather than just lines. And the bases also have to be congruent. So these 2 characteristics have to be true of our bases. Prisms also have something called faces, which in geometry we're going to specifically call a lateral face. And the lateral faces are different than bases. And then lateral edges, which will just be edges, but again in geometry we call that a lateral edge. And then we see over here the side note. The different names for prisms are classified by the shape of their base. So we're going to look at a few examples of prisms and see what those different bases might look like. So here we have a bunch of different examples of prisms. Now these might be hard for you to copy into your notes, so just do your best, maybe try drawing the cube. Some of these harder diagrams, like the pentagonal prism and the hexagonal prism, might be difficult for you to draw in your notes. We will be providing you with pictures of this for your notes when you return to class, so don't worry too much about drawing these. What we do want to do is just follow along and try to identify the key points in this diagram. So let's first find the bases. So we're going to start with the triangular prism. So the base, we said, were 2 congruent shapes that were parallel. Now the base in the triangular prism gives it the name. So a triangular prism, the base is going to be a triangle. So if we highlight the base, we can see that the triangle on top is one of our bases, and the triangle on the bottom is one of our bases. And this is going to be 2 congruent triangles that are parallel. If we extend this plane that has the triangle in it, it will never cross the other plane. So those orange highlighter marks are our bases. Now our lateral faces are all of the other sides of the prism that are not bases. So the blue side right here, this front piece is a face. And then because it's 3D, it's a little difficult to see, but the back, there are 2 more faces. And then again, they're lateral faces. And then the last thing is our edge. Our lateral edges, this is 1 lateral edge, 2 lateral edge, and 3 lateral edges. So the edges are parallel lines that connect the bases. So if the bases are 2 congruent shapes that are parallel, the lateral edges connect the point of this triangle to the point of the parallel triangle with an edge. And that's how we get a prism. A rectangular prism is created when the bases are rectangles. So here again, we can highlight and see that we have a base, and then on the bottom, another base. Our faces are all the other parts that are going around the prism, and then the lateral edges are the pieces that connect the 2 bases together. And all of the edges will be parallel. Here we have the base on the bottom, the base on the top. A cube is a rectangular prism that has squares for bases instead of rectangles. A pentagonal prism has a pentagon or a five-sided figure for a base, and a hexagonal prism has a hexagon for a base. And again, we're going to be working with these figures more when we return to class. So for right now, what we really need to take away is that the bases are the different shapes, and our faces are everything on the figure that is not a base. Then the lateral edges are the parts that connect the two faces together. So moving on, let's look at an example of how we can calculate lateral area of a figure. So one easy way to learn how to draw a prism is to first draw a shape. So we're going to start drawing a triangular prism. So draw a triangle. Then you're going to try to draw the exact triangle, the same size, the same shape. We can see that they match up exactly. But you're going to draw it just a little off on a diagonal. Then, by connecting with a line, you can create your prism. So if I connect the top part of this triangle with the top part of the other triangle, the bottom part of the triangle with the bottom part of the triangle, and the pointy part of the triangle with the pointy part of the triangle, we have a prism. So again, this might be hard for you to draw, but just try your best so that you can get it into your notes. We're going to find the lateral area. What the lateral area is, finding the area of the lateral sides. And we said that lateral sides are all sides that are not bases. So we've already said that this is a triangular prism. Triangular prism makes it sound like a triangle, which means that our bases are the triangles. So the lateral sides are all of the other sides that are not triangles. And now if we look, one of our bases, kind of on the top of our prism, I'm going to highlight that in blue. Right? So we're going to find the blue face and find the area of that. We're also going to try and find the area of the bottom of this prism, and for this purpose we're going to make it pink. And then the last shape we're going to find, pink face, the last face we're going to find is this tiny little back portion, which is the yellow face. So this really takes some visualization practice. So we have a yellow face, a blue face, which is kind of hard to see right now, but it is the top piece, and then the very bottom piece. All three of these are lateral faces. Again, the triangles are our bases. We're not going to include that in the lateral area. So let's start out finding the blue face. Right? If we know that the height of this prism is 3 meters, the entire length across the bottom is 8 meters, and our side piece is 9.1 meters. Right? Starting to find the blue face, we can see that our blue face uses the length that we have here and the width that we have here. So, we need to figure out which measurements match with our blue length and width. We're told here that these are congruent, So if I know this is 8, then I know this is 8. And this is a rectangle, and the area of a rectangle is length times width. So my length is 8, my width is 9.1. So by calculating 8 times 9.1, I get 72.8. So there's one of my faces. My other face is my pink face. That's using this length. And again, this width. And so it's a rectangle. Length times width is, once again, 8 times 9.1. And 8 times 9.1 is 72.8. So there's another face. And my final face is using a different measurement, 3, which is my length of this skinny rectangle, and then the width of this skinny rectangle. And the width, we can see, is the same as the width on the bottom, so this is going to be 9.1 times 3, and 9.1 times 3 comes to 27.3. So to find our total lateral area, the total area of this figure, not including the two triangular bases, we add up all of our faces, 72.8, 72.8, and 27.3. We get 172.9 meters. And that is our total lateral area. So, what you need to come to class ready with is make sure you understand the difference between the faces, the lateral faces, which is what we just calculated with the blue, the pink, and the yellow, and the bases, which our bases are our triangles, highlighted in orange. If you have this general concept down, we're going to talk about this more when we get back into class. See you then.